Uh, Hello, everybody. So my name is Shahin Mehmedov. So it's my pleasure to greeting you from Baku, from Hazar University, uh, for the occasion of the Fourth International Conference on Holography and its application. So first speaker is Vector Meson gravitational form factors and generalized Parton distributions within the software ADS-QCD model by the Minaya Allahverdiyeva from the Institute of Physics, Ministry of Science and Education. 30 minutes, please, you can start.
Hello everyone, dear colleague, professor and participant. I'm Minaya Allahverdiyeva, and today I want to talk about vector meson gravitational form factors and generalized Parton distribution within the software ADS-QCD model. And one of the challenging problem in one of the greatest challenging in modern physics is to understanding the internal structure of hadrons, such as partons, nucleons, and mesons, in terms of in terms of their fundamental building blocks, quarks and gluons. Also, QCD is our fundamental theory of the strong interactions. It becomes non-perturbative in the low energy regime, making analytic calculation near impossible. In that gives the strong coupling in the infrared region makes it has been difficult to find analytic solution. This gives impetus of the formulation of alternative approach to calculate the hadron properties and to make precise predictions in the non-perturbative regime. For the solution, we use any ADS QCD framework models, and our approach is based on the ADS CFD corresponding proposed by Maldacena in 1997, which relates a five-dimensional gravitational theory and the sister space to a 4D gauge theory. Even so, QCD is non-conformal. The ADS QCD model extends this correspondence phenomenology, provides analytic access to hadronic physics. And here we use two models, hardware model and software model. The hardware model introduced an infrared cutoffs to similar confinement, discrete spectral but failing to çevirdim özür. The hardware model introduced an infrared cutoff to similar confinement, discrete spectral but failing to reproduce linear Ricci trajectory. In the software model implement confinement via a quadratic dilaton background, which produce a linear trajectory and avoid sharp cutoff, giving a smooth infrared behavior. And in the software model, wave function obtained through Kaluza-Klein decomposition and satisfies a Schrödinger-like equation. In the software model action, the software model ADS QCD action for a vector meson incorporates a five-dimensional metric and dilaton background. Perturbing the metric by H mu allows us to derive the linearized Einstein equation, leading to the graviton back-to-boundary propagator, and denote HQZ, or in here we for as equation 5. But how we want to calculate gravitational form factors? Because traditionally, much of our knowledge comes from electromagnetic form factor, which probes the distribution of electric charge inside hadrons. But however, to go beyond charge and current distribution, we need to understanding how hadron responds to a more fundamental probe, the energy momentum tensor. This leads us to gravitational form factor, which provide direct information about how energy, momentum, and stress are distribution inside hadrons. Gravitational form factor are particularly important because they allow use to define quantities such as a hadron mass radius, the distribution of pressure and shear forces, and their mechanical stability of strong interaction matter. In other words, they give us access a lot of information about hadron interaction. If you want to find the gravitation, in equation 1, I plus 12 part is given gravitational part, or another second part is given vector sector. Here, phi, k square, and z square is Dalton filed. The background of the model is the five-dimensional ideal space and matrix. A matrix of the space is given by the line element in Poincare coordinates. And here, our variable is changing 0 to 3. That is the holographic coordinate, and mu is diagram element is equal 1 minus 1 minus 1 minus 1 is a four-dimensional Minkowski matrix, and H mu nu is a perturbation of some matrix, and H5n is equal to 0. This, yes.
It is five.
Yeah.
It's same dimension, it's the five dimension. No, how you can compare the four dimension?
After the invariant functions, in here 11 equation 11, we integrate for ds and back to the four-dimensional.
Excuse me. You want to go to the four dimension by
With integral.
no, you should have z to be 0 in the final of your calculations. Because z is your fifth dimensions, yeah?
Yes.
You have four dimensions.
Yes.
Moves.
And next
Z
we add another dimension that we add one z and gets a 5 dimension. After the calculation, we use integer and back 4 dimension.
And is there any relation between your fifth dimension z and the Planck length or Planck scale? Can you bring in your calculations by use of for fifth dimensions? Can you relate your calculations to the Planck scale? Because in four dimensions, in normal, we don't have a Planck scale.
I don't have spelled.
Maybe I don't know because I am not a professional in that. Thank you.
Okay. After the gravitational part, we The gravitational part of the action in the second order of the H mu perturbation causes equation 3, and in here the transverse stressless gauge condition d mu H mu is equal to 0, and this transverse stressless part is equal to 0 also. Then if we calculate the gravitational part, we take this back-to-boundary propagator for graviton, and this back-to-boundary propagator given with gamma function and hypergeometric function u. And the solution was obtained by imposing boundary condition HQ is equal to 0, and in here equation from equation 1 vector part is giving us wave function for vector meson, and in the softwall model ADS-QCD, in the softwall ADS-QCD model, the vector meson holographic wave function are solution of the 5-dimensional equation of motion, and this our wave function is giving a Laguerre polynomial, and in here we take a mean state, and n is equal to 0. Gravitational form factor encodes the internal energy momentum distribution of hadrons, and defined via the matrix element of the symmetric conserved energy momentum tensor is finding as this equation. The energy momentum tensor T mu nu is defined as a variation of the action over the metric tensor G mu nu, which in the weak perturbation case is reduced to the variation over the H mu nu perturbation as equal 7. Our energy momentum tensor is have two parts. One part is a transverse stressless part. Second part is a transverse not stressless part. In this work, we use only transverse stressless part. T H minus is of equation 8. And the matrix element of the light front energy momentum stress tensor operator T plus plus 0 between the Rho meson's initial and final state is expressed by the gravitational form factor as giving equation 9. And in here we have 4 gravitational form factors, and this gravitational form factor combined with Zn, Z2 invariant with Zn and Z2 invariant functions. And in here, our Z2 invariant function is equal to A form factors. Here, M rho is a Rho meson's mass. And little small q square is equal to minus big q square. In our model, in the softwall model, we find that in invariant function in equation 11, and in here, by calculation, the integration of the form factors Z and Z2q with respect to x and z, we can write their analytic expression as follows. And here, Hn is a harmonic number. The generalized Parton distribution provide the three-dimensional pictures of hadron structure, combining information about both longitudinal momentum and transverse spatial distribution of parts. The connect Parton distribution If we want to find the Parton distribution function, we use a gravitational gravitational form factors and generalized Parton distribution related this both variable. The Parton distribution functions a longitudinal momentum distribution and form factor spatial distribution of charge and current. Generalized Parton distribution are dependency variables. First, Xi is a longitudinal momentum fraction, Xi is a skewness, and T is a momentum transverse, and T is equal to small q square. Delta is equal to q square in here, in this model. GPDs encode correlation between the momentum and position of quarks and gluons, revealing the internal structure of hadrons in the infrared framework. And then we want to calculate the generalized Parton distribution for rho mesons, and for the rho meson states of gravitational form factors are defined by the following matrix element of T mu nu. The transverse translates part of energy momentum stress tensors, and in here we have five gravitational generalized Parton distribution. But in this case, in this model, we take Xi is equal to 0 case, and this time we find three generalized Parton distributions, because in here we saw when we take C is equal to 0, our H4 and our H3 going to 0. For this, in translates part, there are E and B form factors is 0 in transverse stressless part. Responding in the GPDs for the mesons as at last can written as follow equation 15. If we want to calculate the gravitational radius or mean square radius, we use the A gravitational form factors, and A gravitational form factors also equal to Z2 invariant functions. And in this model, we find minus 0.27 of mt square for gravitational radius, and it's the good value for this. In the hardware model, find this variable is 0.21, and we find minus 0.27. This radius provides insight into the internal energy momentum distribution of the vector meson. Complement think the charge radius obtained from electromagnetic form factors, and a numerical result from the software model indicate a compact energy distribution consistent with other holographic QCD square. And the result, the gravitational form factors Z1 and Z2 for the rho meson were computed with the software ADS QCD model, and both Z1 and Z2 decrease smoothly with increasing momentum transfer Q square and reflection localizing distribution of energy and momentum inside the mesons. And in the from the normalization condition, we find the Z1 and Z2 also approximately equal to 1, and Generalized Parton distributions H1, H2, and H5 indicates that partons carry most of the momentum in the central region of X, and the transverse structure is encoded in the T dependence. This result provides a quantite and unified pictures of the raw Meson initial structure and demonstrates the predictive power of the soft-wall ADS-QCD model for non-perturbative hadronic observables. And this graph is our result, and in from E and B plus we saw our result very similar in these and other models. Thank you for thank you for your attention.
Any questions? Do you have a question? Okay. Benim sesim gelir orada. Yeah? Okay. So I have a question. Please demonstrate your 15 equation. Okay. How do you obtain these expressions?
Okay, we use this integrals, and first we use this equation is
Okay.
12.
So you got it by direct integration of Parton distribution functions integrals. Okay. Okay. Thank you again. Ha, yok. İnci veririz. Yok, soru arka kaldı. Ha. Gel. Sen gel.